Hi everybody. Today I want to review linear equations one last time as Algebra 2 students with you. So on the screen here I've kind of made up a problem, and then your homework will be to do more problems similar to this. If at any point you want to pause and write all of this stuff down, that might be smart. All right, so I'm just going to pretend with this data set up here and say that I'm stockpiling Trumpy bears because they someday might be really, really expensive, really valuable, kind of like those Babe Ruth baseball cards or something. All right, so like I said, I'm stockpiling those Trumpy bears, and I'm looking into my magic crystal ball, and I know that 10 years from now, if I have two, I'll be able to sell those two Trumpy bears for $1,000. If I have four, I'll be able to sell them for $6,000 total. If I have eight Trumpy bears stockpiled, I'll be able to make $16,000 off of the sale of all those eight Trumpy bears. And then 10 would give me $21,000. All right, so I think that this is a pretty linear pattern. I'm going to tell you right now that it's a linear pattern. And so what I want to do is write a function to represent the sale of my Trumpy bears 10 years from now. Well, linear equations belong to the function family that look like y equals mx plus b, where m is the slope and b is your base value, or what it's what your value is at time zero. All right, so the first thing I need to do if I'm going to write a function is find the slope. You've heard me say it 1,000 times. You can't do anything if you don't know the slope. So take two data sets, like 2 1,000 and then 4 6,000. You're going to use the slope formula, change in y over change in x, y2 minus y1 over x2 minus x1. So 6,000 minus 1,000 is 5,000. Change in x, 4 minus 2 is 2. 5,000 divided by 2 is 2,500. Now, as long as your pattern is linear, your slope should be the same no matter what two data points you use. So just to prove it to you, I chose two different data points. 8 comma 16,000, think of that as an ordered pair, xy, and then 10 21,000, another xy pair. So you can see I did my change in y over my change in x, and that came up with 5,000 over 2, which is $2,500. That's the rate of change. So for every one Trumpy bear I sell, I'm going to make another $2,500. So that's how I move up in my function. This is a positive slope type situation. The more Trumpy bears I sell, the more money I'll make. All right, so then what I can do is I can take my slope and one of these points and write point slope form of the equation of a line. So remember in Algebra 1 and in Algebra 2, I kind of thought of this as like a flow chart. Start with your slope, take your point and your slope and put a point slope form equation on your paper. And then eventually we'll be able to clean it up into something that looks like that, y equals mx plus b. All right, I'm getting ahead of myself. Don't want to spoil the surprise. So I'm going to choose any arbitrary point out of this table. And as you can see, I chose the point 4, 6,000. I just went with this point. I don't know why, I just felt like it. I plugged in my slope. And then from there, so this was point slope form, and I could stop if I wanted to right there. But let's go ahead and write this equation in like function notation or in slope intercept form. All right, distribute in the 2,500. That gives me 200 or 2,500x minus 10,000. Move this constant over by adding it to both sides. That will get the negative 6,000 and the positive 6,000 to cancel. And then now I have y equals 2,500 or 2,500x minus 4,000. All right, so my function notation then, I can just replace y with f of x. F of x is just a fancy name for y. And then I can use this function to find, if I stockpile 20 Trumpy bears, how much money am I estimated to make, or what do you think I'm going to make in 10 years if the price of these Trumpy bears really does appreciate, whatever. I'm just making this up. I should probably insert a disclaimer here. I do not have a Trumpy bear. I do not want a Trumpy bear. Never will I ever buy a Trumpy bear. I just have seen those ridiculous commercials on TV, and I cannot believe that they're selling something as ridiculous as a Trumpy bear. All right, so plug in 20, 2,500 times 20, and then subtract 4,000, and that gives me $46,000 if I have 20 of them to sell in 10 years. So that's how you that's a crash course in slope-intercept form, or the linear function family. Writing in point slope form is just quick and easy. You can manipulate it down into slope-intercept form, and then a function can be evaluated at any point you want. All right, now just a friendly reminder that if you have parallel lines, they will have the same slope. If you have perpendicular lines, their slopes will be opposite reciprocals. So if my slope of one line is 2/3, the opposite reciprocal will be -3/2. And this upside down t, remember, is just perpendicular notation. You can do anything you want if you're given parallel and perpendicular lines. Remember, if you have a slope, you can do anything you want. Take a slope, find an arbitrary point or just some point out of a table value, a table given, or maybe they're going to give you an actual point, XY coordinate pair. So I think that's pretty much all I have to say about that. I hope you are winding up the semester, you're getting your makeup work in. If you have any questions, please let me know. Send me an email and I'll try and help you out. All right, bye guys.